This is the OpenHPI course Linked Data Engineering, Lecture 1, Linked Data and the Web of Data. In this part of the lecture, we want to talk about linked data and the linked data principles which are behind linked data. First, let's have a look at linked data. Linked data is nothing else but the current web of data, and this denotes publicly available RDF data in the web, which is usually identified via a web identifier, which is a URI, a Uniform Resource Identifier, and is accessible via HTTP. You see here that URI and HTTP, they form something like a uniform or universal API with which I am able here to access the data. The next unique point about linked data is, of course, that linked data is linked with each other. So an entity in one data set might be linked to another entity in another data set. And of course, this is again expressed with the help of URI. So this is the basic building block of RDF and the basic building block of linked data on the web. Overall, there is a huge set of data sets, overall almost 10,000 data sets up to date, with more than or almost 150 billion facts and with about 800 million links between them. So this is really, really huge. And if you use one of these links that I have provided here on the slide, you can get a short glance and a look at the current state of the web of data of linked open data. So just have a look on that to get an idea of the current state of the web of data. Okay, how do we get there? First, let's have a look at a website which makes use of linked data. So one of the very prominent websites that make use of linked data is the BBC website. BBC was also one of the first companies that made use of linked data in a commercial setting, simply for keeping their many websites related to the BBC program up to date. If you do this in a manual way, of course, this would require much labor. And of course, also if you want to try it, or if you try to do it in a conventional way with the help of screen scraping or accessing via specialized APIs, other kind of databases to get current information into your website, this is also a lot of work because you don't have a standardized API. You have to use different APIs. They are subject to change. And then, of course, you have to invest a lot in maintenance and stuff like that. It's better here to use a universal interface like the linked data interface, and BBC has done that, and combined publicly available data, for example, stemming from DBpedia, from MusicBrainz or Last.fm, and combined this current up-to-date data on their website by automatically integrating this into the website. We will get back to that later. In the traditional web, data can only be found if it is available via some website. So usually data here which resides in a database, is connected to a web server, and the user usually gets only to the data via the web server. So with a browser, I interact with the web server then interacts with the database and the web server, they follow a specialized protocol. For example, they can follow JDBC, and then the web server and the browser, they exchange their messages with HTTP. So this would be the traditional data exchange with a human user in the line. If you want to have a program or a machine which reads the data directly then from the database, you must use proprietary web APIs, which are available for many databases. So you can use, for example, an API to communicate with Google. You can use an API to communicate with Amazon or with other huge websites which provide data from databases. The problem here is only that then, of course, you could combine this data by accessing different databases via different web APIs and then create a mashup, which, for example, puts all this data in relation and creates something new out of it. But the point is, all these web interfaces, they are different. So you have to adapt your program especially to all of these different web interfaces. And of course, also these web interfaces are subject to change. So you have to change then again your connection to the database if the web API changes. So this in the end sums up to a huge effort. So it would be nice to have a uniform, unique, universal interface to access data on the web. And this, of course, you can do with linked data. So the problem is, In the web today, data is locked up in so-called small data islands, and other applications usually cannot access this data. So you have to use this special proprietary API. So you cannot use your Google API to access Amazon data and vice versa. So this is rather proprietary. You end up in these small islands. So the point is to get from one island to another, or to connect these islands, you have to climb over really high walls, and this of course means lots of cost, lots of expenses that you have in solving this difficult task. How do we get rid of these closed data islands? Simply by applying linked data technology that we already have heard of. Because linked data is structured data available on the web, and this data follows a simple unified API. The unified API means all data is structured according to RDF, so RDF is the general exchange data format, and the access usually is performed via traditional web technology. So you access via HTTP, and data entities are identified via URIs. This also means fine granular access. You do not only access the entire dataset, you can explicitly reference a single piece of data within a dataset with the help of one URI. So this is a huge benefit. So using RDF, of course, is one of the few building blocks. This here sums up all of the 4 linked data principles. Let's skip through them. So first, use URIs as names for things. So we can name, of course, every web resource, but also every resource in the real world, and assign a URI to it to identify it. So in the next part of the lecture, we will talk in more detail about URIs and how to use them. Of course, this should be HTTP URIs, which means via HTTP you should be able to look up the URI and to get more information about the entity which is behind this URI. So this is the second principle. And the third principle says, okay, so if I look it up, provide useful information. And of course, you should use to provide this information the according standards, which mean RDF, the Resource Description Framework, or for example, Sparkle, which enables me to make sophisticated queries over linked data. And in the end, which is probably the most useful feature of linked data, is you have to include links to other data sets, because the more links I provide, the more data I can relate with each other, the more easier it will be to understand the meaning, the content of this data, and to use this in a global interactive session or way. So if you include links to other URIs, you can discover more interesting things in your application. So these 4 points make up the so-called linked data principles. And following these linked data principles, BBC has built up its website where information is dynamically aggregated from external, publicly available sources like Wikipedia, MusicBrainz, Last.fm, or another thing it's called Discogs. The point is they do not use any screen scraping from these websites. They do not use specialized API. All of the data there is available as linked data, so they make use of it. They simply access this data via HTTP. And the data then on the website is presented always in an up-to-date manner without manual interaction. And this, of course, is a huge benefit because it can save you a lot of costs. So look it up, BBC website, there you can see first use of linked data in a commercial setting. And by the application of the linked data principles, we come up with a so-called web of data. So this is this huge cloud that we have seen. This all started about 2007 with a few data sets, as you see here, all centered around DBpedia, which we have already learned of. And there was also data from the US Census, for example, or FOV data, which is a person network data, or MusicBrainz, which is data about music and stuff like that. And this quickly developed. You see already in the end of 2007, lots of new data sets have become part of the linked data cloud. Then 2008, it's still growing, 2009, 2010, 2011. And this is the last picture we have from this huge linked of linked data web, and on the website, on the links of the website that I gave you previously, you can access the most recent diagram of the linked data web. Only to give you a brief or a short glance of what is behind this web of data. And it's a huge space, a huge database of interconnected data sets. If linked data is used in an open fashion, in an open source fashion, it means if the data is publicly available, then it becomes linked open data. Of course, you can also apply the linked data principles in a closed session, for example, in a company. You do not necessarily have to have links to the outside or grant access from the outside. Then you have linked data. But if it's publicly available from the outside, you have linked open data, and Tim Berners-Lee, the creator of the semantic web and also of these linked data principles, has come up with a 5-star criteria for linked open data, and then you can, for example, qualify the data that you present with this 5-star schema. And the 5-star schema goes like that: you will earn 1 star if you make your data available on the web with any kind of open license. Then it's open data, it's 1 star linked open data, no matter what kind of format you use. So you can also use some proprietary format, for example. It's 2-star data if this data is machine-readable structured data. So if you follow a specific coding convention, so for example, Microsoft Excel data is already some machine-readable structured data, then you have 2 stars. So if you only scan a table and put the picture of this table on the web and make it publicly available, you only have 1 star, because this picture is not necessarily machine-readable. 3 stars you earn if you use a non-proprietary format. So for example, if you use a comma-separated CSV, which means comma-separated values, instead of Excel, this is publicly available. It's not a proprietary format, it's an open format. Then you earn 3 stars. And by using open standards from the W3C, which means RDF or Sparkle, you will earn 4 stars. And of course, you can guess now, the last star, the 5th star, you will be granted the 5th star if you link your data to other people's data. Then you have original 5-star linked open data. So these are the linked data principles. And in the next part of the lecture, we will start with the first and most important thing in linked data, which are URIs, which are used to identify and to reference things on the web.